All right, so today we're going to work on lesson 5.8, area models for fraction multiplication. So we're going to apply some of the multiplying fractions strategies to help us with area. So we're going to use area models to find fraction products. Remember, products are just answer to multiplication problems. Apply and extend previous understandings of multiplication division to multiply and divide fractions. All right, so the first part here, we want to get warmed up. So we're going to look, this will write true or false for each statement. 5/10 is less than 49 hundredths. And remember with that, if you wanted to compare, you could always add a 0 to the tenths to make it hundredths. But you can also just look at the tenths place, and you can see that the 5 is greater than 4. So that would be a false statement. 1 and 88 hundredths is greater than 1/9. Again, I look here, I look in the ones place, and they are the same digits, so I go to the next one. 8 and then 9. So 1 and 88 hundredths is not greater than 1/9, so that would be false. 12 and 35 hundredths is less than 12 and 4/10, so I can see the 12s are the same, so I go to the first digit that doesn't match. So the tenths place, I can see the 3 is less than a 4, so that is a true statement. So then you can take the time to go through those. So then you would want to pause the video, just write those down, and make sure you understand how to compare those and tell if they're true or false. Okay, so now we're going to talk a little bit about some vocabulary here, just to review. An area model for multiplication problems in which the length and the width of a rectangle represents the factors and the area of the rectangle represents the product. So you can see here we have 3, and over here we have 1, 2, 3, 4, 5, and so it's a 3 by 5, 15. So that's an area model. All right, so just to review again too, factors are whenever two or more numbers are multiplied to give a product, right? So you can see here they did 4 multiplied by 1 and 5/10, and it equals 6. So 4 and 1 and 5/10 will be the factors. And another word that came up when we did order pairs is horizontal. That's when you go from left to right. Okay, this would be horizontal. This line would be vertical. And then product. The result of multiplying two or more numbers. And then, like I said before, vertical is an up and down line. So you want to fold and shade a sheet of paper to find 2/3 of 2/3. So discuss with a partner, compare your work. So if you're at home, you may not be able to do that, but you can at least draw out a model for it. So remember, in previous lessons, we drew a rectangle. So go ahead and pause the video now and do that. All right, I'm going to show you my model for 2/3 of 2/3. If you remember previous lessons, we look at the second fraction. It tells me that the whole thing is split into 2/3, and I need to shade in 2/3 of the rectangle to start with. And then the first number, if you remember from previous lessons, the denominator tells me how many to split it into again. So I'm going to split it into thirds again. I'm going to go the opposite direction. And then the numerator of that first fraction tells me how many pieces of double shade. So I need to shade in 1, 2 pieces. So I need to shade in 2 here and then 2/3 here. Okay. And so when I do that, I should get 4/6. So 4/9. So 1, 2, 3, 4 pieces shaded out of 9 total. So 2/3. So 2 out of every 3 pieces needed to be double shaded. So 1, 2 out of 3, 1, 2 out of 3. Now, theirs looks a little bit neater than mine, but it says first I fold the paper into thirds, shaded 2 of the thirds, and I fold the paper into thirds the other way and double shaded 2/3 of the shaded part. The paper has 4 parts and 4 of them are double shaded, so 2/3 of 2/3 is 4/9. And remember, you can always check your product by simply multiplying straight across to C. So what number sentence could you write to represent this problem? Just like I showed you here, you could just say 2/3 times 2/3 would be the same thing as 2/3 of 2/3. All right, so as you can see here, is the product greater or less than the factors? Why? So let's think about that. So our factors are 2/3 and 2/3. Is each factor greater than the product or less? Well, we're multiplying, so we know that it should be, the product should be larger, right? Because you're multiplying, so you are getting greater there, is what we would normally think. But that's a little confusing, isn't it? Actually, that would not be correct because we are finding the fraction of a fraction. So we're finding a smaller part. We're not finding a whole now when we multiply. So it would actually be smaller. So a common misconception would be that if we multiply, it automatically gets larger. Right? So folding and shading paper is one way to find fraction products. And we can also look, and I know that 2/3 is more than half of 3, and 2/3 is more than half of 3. So each factor is still greater than the product because 4.5 is half of 9. So you got to be very careful with that. So today you'll explore a different way to find fraction products using what you know about area. So turn to Math Journal page 176 and examine the diagram in problem 1. Now, there are two number lines, one horizontal, one vertical. Each of the number lines show the intervals from 0 to 1. So how should we label these tick marks? And these are our tick marks here. You can see they're blue. And that one's labeled for us. That one and that one's labeled. Well, let's see. As I go across, I see it's 1, 2, 3. It's split into thirds. So the first block would be 1/3 then. The second block would be 2/3. And we know that 3/3 is equal to 1. So we don't need to put thirds on the 1. If I count here, I go 1, 2, 3. So again, it's thirds. So the first block would be 1/3, second block 2/3, and then you have 1 whole. So, and again, the reason we would label those is we're just seeing how many pieces there are. So this first block is 1/3 of the whole thing, of that side. Okay, so again, label tick marks. We already did that. So you should have those labeled as thirds. So what do you think the diagram is? Why do you think the diagram is called an area model? So let's think about that. How does area relate to multiplication? So think about the formula for area is length times width. And how does this area model show the product of 2/3 and 2/3? So think about that. When we look at area model, we look at length times width, right? And so the 1/2 could be the length, the other could be the width. And when we multiply those two together, we end up with the area shaded. So can we find the area shaded without multiplying? So the big square is 1 unit long and 1 unit wide. So the area is a square unit. This means the area of the shaded rectangle is a fraction of a square unit. So what fraction of the big square is shaded, and how do you know? So think about that. We already labeled it with tick marks, right? So how do we know what is the area of the shaded triangle, or sorry, rectangle? So if we go back up to here, we could look at it again. We have our tick marks, right? 1/3, 2/3, 1/3, 2/3. Now, as I look at this, I can see there's 1, 2, 3, 4 shaded squares in the rectangle. So that would be my numerator, and my denominator is the whole number of squares I have. And let's see, it's a 3 by 3, so it would be 4 ninths on the area that is shaded. So you know the length, width, and the area of the shaded rectangle now. Okay, so what multiplication number sentence can we write to represent the problem? So we know it's 2/3 of 2/3 shaded, right? So we know we could rewrite that as 2/3. And because it's area, we want to multiply length times width. So we could say 2/3 multiplied by 2/3 gives us 4 ninths. Now, again, area is length times width. So students can use a number line to determine the length and width of the shaded rectangle, in this case 2/3 unit and 2/3 unit. The area of the large square is 1 square unit. Students could find the area of the shaded rectangle by figuring out what fraction of the square unit is shaded. In this case, 4 out of 9 equal parts are shaded, which is what we did. You can also think about length times width. The area of the shaded rectangle is the product of the length and the width. In this example, 2/3 multiplied by 2/3 is 4/9. So the length and width of a rectangle are also called the dimensions of the rectangle. So that's important because you may see this word come up and you may be, dimensions, what are you talking about? Maybe a little confusing. But dimensions simply means the length and the width there, the measurements of a shape. Okay? So go ahead and pause the video. You're going to work on Math Journal 2, page 176. So work on that as much as you can. All right, so after pausing the video, you hopefully took a shot at this to try. We're going to go through it together and kind of see what we get and see, hopefully you're picking up on this. So it says the diagram shows one way to represent 2/3 by 2/3. What are the dimensions of the large square? So remember the dimensions are length and width. So first I'm going to label my tick marks. Now, it says of the large square. That means this whole thing, okay? And so I look, it's a 3 by 3. So because I look, there's 1, 2, 3 by 3 units. Or actually, instead of 3 by 3, we would just say 3 unit by 3 unit. Because there are 9 total squares. What is the area of the large square? Well, we know that when we take length, the length times the width, we get 3 times 3, which is 9. So there are 9 square units within that shape. What are the dimensions of the shaded rectangle? So I'm going to do a little racing on some of these marks here. And as you looked at this, you should have noticed with the shaded rectangle that it's 1/3, 2/3 this way. So 2/3 by 2/3. And then we know for the area, we could do length times width, or in this case, we could simply count and see that there's 4 out of 9 total squares shaded. Now, so think about the multiplication for the shaded area. We know it's length times width, so we know the length is 3, and we know the width is, 2/3, and we know the length is 2/3. Width and length are both 2/3, so I could write my multiplication sentence. I get 4/9. So hopefully you got that. Be a little bit tricky. You really got to take the time and read the language on there. Okay. So the first step here says label the tick marks. Last time it was thirds. We got to be careful. It's not always going to be thirds. So let's see. 1, 2, 3, 4. Okay. So it's fourths. So this would be 1/4, 2/4, 3/4. And again, it may not be the same going up. Let's see. 1, 2, 3, 4. So in this case, it's a square, so it works. What are the dimensions of the shaded rectangle? Okay, this case we go, look, 1, 2, 3/4. We look here, it only goes over to the 1/4, so it's a 3/4 by 1/4 for the shaded part. What's the area of the shaded rectangle? So again, you could do it 2 ways. You could count and say 1, 2, 3. And then you could say it's a 4 by 4, so you know there's going to be 16, so 3/16 is shaded in. Or you could just multiply 3 times 1 and 4 times 4. So now I want you to take a minute, pause the video, go through the rest of this. So you're going to write your multiplication number sentence, and then you're going to label the tick marks for the next one, and then we'll come back and look at the answer. So again, pause and take time to work on this now. All right, so we're back. So I'm going to reveal the answers here. So hopefully you've already done this, so you can check your work to make sure that you have the same answers. So you can see the first one there we already did. 1/4 times 3/4, 3/16. And your multiplication sentence will be 1/4 times 3/4. All right, so the next one you should have already done. You should have labeled your tick marks first. And you can see here at the bottom, this one is in thirds, but the going up, it's in fourths. And so you would just count over and see that you have 2/3 by 2/4, and then multiply those. Now, if you go back to the diagram and on journal page 177 and look at problem 1, you have something that says 3/4 times 2 6. So first we'd want to label the tick marks on here again. So I have 1, 2, 3, 4. So 1/4, 2/4, 3/4. And but I don't want to assume that this is force going up, and I can actually see right here it says 6. So let's see. 1, 2, 3, 4, 5, 6. So 1/6, 2/6, 3/6, 5/6. You want to write a little bit neater than I did. It's harder on the board. Okay. Now I could shade up to 3. Let's see. First one is 3/4, so I could shade over 3/4. So I'd shade over to 3/4. The second part says 2 6. So then I'm going to go up 1, 2, 6. And I'm going to go back over here, and I want to make sure I shade all that in. Okay. A great way to check if you've shaded the correct amount is to go ahead and multiply those, and I get 6/24. So I should have 6 parts shaded in, and I can see I have 1, 2, 3, 4, 5, 6. All right, so that's how you can check your shading on that. Right, so you're going to follow the steps using the diagram at the right to multiply 3/4 by 2 6. So you're going to label tick marks and do all those things that we did. So go ahead and pause the video and complete that shading now. Okay, so now let's go ahead and look, see if your answers match up to what we have. And just like we labeled it, you can see it's a little bit neater than what I did. And in your book, you should be able to use a pencil and write a little bit better than I can on the board there. Okay, so then you're going to pause the video again. You're going to complete Math Journal 2, page 177. So same deal. You're going to label the tick marks. You're going to shade the rectangle with the given dimensions by the area of the rectangle. So they already tell you that you're working with fifths and thirds. So we can see down here across the bottom, it's going to be the fifths, and then going up, it's going to be thirds, right? So you want to make sure that you label that. So let's look at this one together here. So the first one is, I got a label. So 1/5, 2/5, 3/5, 4/5. And I got to label up 1/3, 2/3. So it says shade 3/5. So I go over to 3/5. I stop. I shade that in. Now the second fraction tells me 2/3. So now I'm going to go up 1, 2/3, and I'm going to go all the way over to make sure it's completely filled in to the 3/5. Again, a great way to check your answer on this is just simply multiply, and I should have 6/15 shaded in. And if we look, I have 1, 2, 3, 4, 5, 6 out of 15 squares shaded. So let's go ahead and look. You see if your answers match up. Okay, so you can see there's 6/15. All right, so if you haven't already, pause the video and complete number 3. All right, so hopefully you've completed number 3 on your own. So let's see. Hopefully you're getting the hang of it there. You can see on this one, they told us to go over 5/6. So we did that. And it said only go up 1/4. So that's why there's only one row. Again, you can check your multiplication against your shaded area to see if it matches. Okay, and this is the home links that you can do for extra practice to help you with the lesson. All right, thank you.